Afternoon, everyone. Welcome and thanks for coming. My name's Steve Coshall. I'm the sales leader for the UK and Ireland for a company called CombiSafe International. And today I'm here representing the EPF, which is the Edge Protection Federation. It's quite a new organisation, actually. It's one of the newer trade associations in the construction industry. And this is who we are. This is what we do. So the Edge Protection Federation, basically we're the trade association, the area of expertise for the field of edge protection in construction. So the purpose of our organisation is basically to provide an area for expertise for the industry. So we're there to provide an area of discussion amongst industry peers. We offer guidance when it comes to training and education. We do a lot of work on raising awareness. We offer guidance on what you see here. This is our code of practice on the right, the little picture there. So this is our best practice document that we've created at the EPF, and this is available for the construction industry. This tells the industry what to do in terms of edge protection, how it should be tested, what it should look like, how it should be used, this kind of thing. And it's all generic, so there's no product specifics in there. Overall, though, in summary, what we're really trying to do is raise the benchmark. So we're trying to educate the industry and raise the general level of awareness and ensure that everyone is competent and that they know what they're doing. So that's really what we're striving for. The federation itself was formed by the companies you see at the bottom there. Those are the founder members. So there's some quite large and reputable companies in there with a lot of experience in the world of access and formwork and scaffolding. And these companies do add a great deal to the Edge Protection Federation. There's a wealth of experience in there. Just in case you're wondering who CombiSafe are, obviously I work for CombiSafe, and we were the original edge protection provider. We developed the first systems about 25 years ago. So we brought them over to the UK. When we first came over to this market, there wasn't really anything like an edge protection system. That didn't really exist. You know, if you wanted edge protection on a structure, you basically used scaffolding, tubular guardrails. So systems that, like you see here, they just didn't exist before. It was very much traditional tube and fitting. So there's been quite a lot of change in the industry over the last 10 to 12 years. So what is edge protection and where would it be used? Well, really we're talking about a system to protect the leading edge of a structure to prevent a fall. So that could be a whole manner of building projects. Obviously, a few examples here, not limited to these examples, of course. Mostly offices, civils, steel frame buildings, concrete frame buildings, excavations. Obviously, you don't necessarily have to be up on a structure to be working at height with the risk of a fall. Excavations are no different. I've added something at the last minute, actually, vehicles here. Although vehicles aren't actually covered under the European standard, we've kind of encapsulated it under our own EPF umbrella because when the work at height regs were launched, there was this immediate problem of the risk of fall from vehicles when loading or offloading materials. So we've kind of added that to the mix, edge protection on vehicles. There are many, many ways to fix these systems to the building, which I'm not going to bore you with. Suffice to say, there are a whole manner of fixings to fix onto concrete slabs, onto steel frame buildings, industrial steel frames, buildings much like this, actually, where you've got very large spans between the columns. Structural timber frame buildings as well. And flat surfaces as well, like roofs. So lots and lots of different ways of fixing this equipment. All of them have to be tested and compliant to EN 13374. This is the new standard. Well, not so new, actually. It's been around for nearly 10 years now. But this is the benchmark in the industry for temporary edge protection. So before this system came out, there was no reference point in the industry. There was no benchmark at all. Whereas now, if you're providing edge protection on a structure, you have to provide a system that adheres to this standard, 13374. Again, lots of other fixing methods. Precast concrete is a big talking point in the industry because it's moving towards more sustainable methods of construction and off-site fabrication. Obviously, that's a big talking point. You can fix this stuff to formwork beams, sheet piles, bridges. You see quite a lot of these systems over motorway bridges these days. The point I wanted to make here, though, really, just a kind of walk-away message, is the system is only as good as what it's fixed to. So obviously at the EPF, we ensure that these systems are designed and tested to meet the standard, which is 13374. But these things are only as good as the structure that they're fixed to. So you have to ensure that the structure is sound and it will withstand the loadings required to meet the standard. You're probably aware of the work at height regs. Obviously, it's not a particularly new regulation, but it is law. And you know, in construction, we have to adhere to this legal standard. And in the edge protection industry, we're trying to move more and more towards working without the risk of working at height. So the picture that you see on your screen at the moment, that's working in a way that's conducive to the work at height regs. For those of you that don't know, the work at height regulations have this strict hierarchy when it comes to practice on site. So avoid work at height, prevent, and then mitigate. So the example you see on your screen here, this is right at the top of the hierarchy. So this is avoiding the need to work at height altogether. So what we would typically do is work early in the process with a steel contractor, for example. We would tell them where to drill all the holes ready to receive a system like this. And then when the equipment turns up on site, when all the steel work turns up on site, it's ready to receive the safety system. So everything's done on the ground. There's no work at height. Everything's installed onto the beam. And then, as you can see in this picture, it's craned up the building and then brought into the structure and fixed. So there's actually no one up there on the structure installing this equipment. So this really is the way that we should be working more and more, reducing the need to work at height altogether. But it really does emphasize the need to get in early in the process, though. Obviously, if we turn up too late and the structure's already going up and we miss the boat, then that would mean someone getting up there on the building and actually drilling holes and fixing this equipment. This little graph that you see on your screen now, I've included this because you've heard me mention 13374. This is the standard for temporary edge protection systems. This graph that you see here on the right, this actually shows you, this is in the back of the standard, by the way. It's in an annex at the back of the standard. And this shows you the new thinking that we have to apply to construction projects now. So 10, 15 years ago, when this standard didn't exist, you could simply put up a scaffold system as edge protection, and you know, that was compliant. That was fine. Nowadays, it's a bit more complex than that. You really do need to think about the application and, more importantly, the slope of the structure that you're fixing this to. So that's the slope of the slab. So what we're saying now is that if you've got a flat slab, so that's what we call a Class A application. That's up to 10 degrees, by the way. That has to be tested to meet a static load only. So that's basically a guy standing next to the edge protection and leaning on it. So that's Class A, up to 10 degrees. Then you're up to Class B, which is a sloped surface up to 30 degrees. So if you've got a sloped surface on your structure of greater than 10 degrees, then you have to provide a Class B system, which might look slightly different to a Class A. So Class B not only has to meet the static load test that we have to apply to Class A, which is someone leaning against it, but because it's on a sloped surface, you've got the potential for an impact there as well. So we have to do what's called a load dynamic test as well, which is like a big swing bag, basically, to simulate the impact of a person hitting the edge protection at the bottom of the slope. And then, as you can see on the graph, Class C, this is for surfaces greater than 30 degrees, up to 60. Now, if you think about a sloped roof, for example, at 60 degrees, someone falls on this sloped surface, the potential for impact at the bottom is pretty huge. So if you've got a solid barrier there, you could, the guy could be severely injured or even killed with that kind of impact. So Class C is more about slowing the guy down rather than just stopping him in his tracks. So Class C doesn't have to withstand the static test of someone leaning against it. You could have a net barrier solution in there, for example, some tension netting, because it has to withstand such a high force, a high impact. So Class C is a very different kettle of fish. This is just really about slowing the guy down and containing him rather than stopping him. So I hope that makes sense. But this is quite important because, as I say, nowadays this is the standard that we all have to adhere to, and we have to think about these things now. So just a few examples quickly of what I would call entry-level edge protection. This is kind of the standard edge protection that you need to provide now to meet the requirements. So this is best practice. So as you can see, lots of different barrier type systems here. On the market, there are probably 8, 9, maybe even 10 providers of this type of system now. And you can fix them to pretty much anything on the structure, as I've already said. I just spoke about Class C applications. This is an example of a Class C system. So as you can see, you've got a guy working on a roof there. Not a great example, but if you imagine this roof on the left was sheeted out, and perhaps it was a steeper slope, if he was to fall and hit the edge protection at the bottom, it's, like I say, a massive impact. So you have to think about containing the guy rather than just stopping him. So the system you see there on your screen, the worker can't actually leave the building. So if he does hit the barrier, he's contained basically in the horizontal netting underneath. So he's completely cocooned on the structure. So yeah, this is a Class C application. Not something that you could use on a flat slab though. There are various freestanding systems on the marketplace now as well. This is a typical example of something that you might see on a flat roof. So this is freestanding. It's not fixed in any way. And for that reason, because it is freestanding, you need to use counterweights to provide the sufficient protection against an impact. So as it's only Class A, so it's only up to 10 degrees, it's just got to withstand the force of someone working up there and perhaps leaning on it or tripping and falling against it. So that type of product is fine for a flat surface, but nothing greater than that. There's been quite a lot of developments in the world of edge protection in the last few years, particularly in the UK, more so than any other country in Europe. A lot of the big contractors now, especially the likes of Lend-Lease and Carillion and Mace, these guys are now pushing the industry in a certain direction, and that direction is basically more. So that's much higher levels of containment and a much taller system. So they're looking for more safety, basically. So the standard 1 meter high system is not really acceptable to some of the bigger contractors these days. They're looking for much more levels of containment and smaller porosities to protect from wind-blown debris and anyone that might be actually working up there at the ceiling level. On the same note, what you're looking at here on your screen is a system that goes all the way from the floor to the soffit. So it actually uses a friction fitting, jacks between floor and soffit, and it provides you with a full height containment system. So that's edge protection all the way up to the soffit. This is very much a UK requirement. In the rest of Europe, many other countries are happy to work to the standard 1 meter high system, whereas in the UK, our major contractors are looking for a lot more. We also have a standard that was written by one of the member companies. This is what we call the containment standard. Because there was no benchmark when it comes to full height containment, we thought it was best to drive the industry and actually write our own standard, which took a couple of years, and it's now been endorsed by the EPF. So there is now a reference point when it comes to full height systems that go all the way up to the soffit. Just a quick example here, timber frame. Timber frame has been very much playing catch up over the years. And now it's quite common to see these type of systems used on timber frame buildings, even erected on the floor and craned into position, as you see here on the right. This is a friction post. I've already described this, but this, again, jacks between floor and soffit, really, really quick to install, and it's not fixed at all. So it's just relying on friction force between the floor and soffit. Many of you will have seen these climbing screens on the big projects these days in inner cities. So this is a full mesh that covers maybe 2 to 3 stories and offers edge protection and protection against wind-blown debris as well. In the same way, you can protect stairways these days as well. It should be thought of as it's in the same way as you would edge protection on the edge of the building. You've still got a potential for a fall into the stair void itself. So you can easily attach systems to the actual stairs as well on precast concrete or steel. These are protection fans that you see here. Strictly not edge protection. It should be used with an edge protection system, as you see on the right. But these systems are used these days in inner cities to protect the public working below from falling debris, and also site workers, obviously. So it's a much safer alternative to a traditional scaffold solution that you see around the perimeter of a building. And these can be craned up the building as well. So these will actually rise as the building progresses. I mentioned falls from vehicles earlier. When the work at height regs were launched, this was a real problem area. Obviously, you can use crash mats and airbags, that type of thing, but that's actually allowing the person to fall, which we should be trying to avoid. Remember the work at height hierarchy. Wherever possible, we should avoid work at height, but we should be trying to prevent a fall as well. So edge protection systems on wagons, that's exactly what that's doing. It's preventing the possibility of a fall. There's been quite a few special developments in recent last couple of years. On the left, I think you see a picture of a lift shaft edge protection. So this is protecting the potential of a fall into a lift shaft itself. This is a full height system. And excavations as well at the bottom there. Again, work at height should not be thought of simply as working up on a structure, but there's always the potential of a fall into an excavation as well. So that needs to be considered in exactly the same way. So finally, there's been a lot of progress in the world of edge protection in the last few years, but there are still plenty of challenges. Firstly, edge protection on a structure is not actually recognised as part of temporary works. So still some work to be done there. It's often not considered until late in the process, sometimes too late in the process. As I said earlier, the earlier we can get involved in the process, perhaps at planning stage, tender stage, that's when we can add the most value to any project. That's when we can add most safety and we can save costs. The later it gets, for example, when the tower crane's up and the building's climbing, then there's more work to do, obviously, and there's the threat of having more work at height. In the UK, a lot of the major contractors now are actually looking to work in excess of the standard. So in the rest of Europe, we're happy to work to this standard, 13374. But in the UK, the major contractors are looking for more. So that does pose a challenge in itself. Some of the optimum steel designs on buildings these days, we're looking for lighter weight, obviously, more efficient steel members being used. This does pose us a few challenges, actually. So that does cause a few problems for edge protection systems sometimes. I mentioned earlier that full height protection is a big development in our industry. The problem we face is that there's no client consensus. If you ask the top 10 contractors in the UK what full height containment should look like, you'll get 10 different answers. So that, again, is a bit of an issue. And even though the EPF are obviously working really hard to try and raise the benchmark when it comes to training, there's still a lot to do there. There's still a lot of people using edge protections out there in the marketplace that aren't adequately trained. So that's something we're working on very hard at the moment. And some of the really unusual building designs that you see these days, like the Shard, for example, the Gherkin obviously was another good example. Some of these really unusual building designs, they really don't lend themselves that well to edge protection systems. Obviously, we need to be thinking about CDM and designing safety in as early as possible, which unfortunately isn't really happening as we'd like to see it. Okay, so that was a very quick snapshot of innovation in the world of edge protection. Obviously, if you want to know more, or if you need guidance on this subject, the best port of call would be our website, as you can see on the bottom there, the EPF website. So if ever you need guidance, send your questions there, and we'll take a look at them. Thanks for listening, everyone.